Anyway, once these math things are done, basically you will be ripped apart exactly at the Schwarzschild radius when capital M is 2000 solar masses. For lower mass black holes, the R rip is going to be greater than R Schwarzschild. So you will be torn apart before having a chance to reach the event horizon. This is why they're saying if you don't want other people to see you getting ripped apart, you should pick a higher mass black hole. If you want to see what life is like inside an event horizon, be sure to choose a black hole with mass much, much greater than 2000 solar masses. You can curl yourself into a sphere to decrease your height, but this delays your tidal disruption by only a small amount. So if you want to feel less tidal forces, the rip apart is going to happen because of the tidal forces across your body, because you have a height. You're not a sphere. So because the ripping apart will kill you, if you don't want to be killed before entering the black hole, then you might want to choose a black hole of a higher mass, basically. If you want to dive into a black hole, you must first find a black hole. This can be difficult since, after all, a black hole is black. We can, however, detect black holes indirectly by their gravitational effects on nearby matter. So you'll be surprised that black holes, do affect things around it enough where sometimes they can give themselves away. Consider, for instance, a black hole that is in a binary system with a normal star. If the normal star, as it evolves, swells until it is larger than its Roche limit, the tidal force exerted by the black hole will be great enough to strip away the outer layers of the star. So just like we were talking about tidal forces on somebody jumping into a black hole, tidal forces can even happen on other things that are near the black hole. The stripped gas, such as the outer layers of the star. So actually a black hole, depending on which black hole, where it is, whether it's in a binary or not, can start to basically strip the outer layers of a nearby star. And of course, this happens because the outer layers of a star are going to be the more gaseous, the more loosey-loosey, goosey-goosey type parts, right? So the stripping is easier for that. The stripped gas, as it falls toward the black hole, will be compressed and heated to 10 to the 6 Kelvin or so. Wow, that's quite a bit. Since the falling gas will have some angular momentum, it will generally form an accretion disk around the black hole. The disk of hot gas will be detectable from the X-rays it emits. So this is actually one big giveaway that you're close to a black hole, or there's a black hole in the surroundings, is all the stuff that you can get from the accretion disk of hot falling gas, and from the X-rays that can emit. So once again, if you want to dive into a black hole, you should pick a higher mass one. We did some math to figure out that if the mass of the black hole is much, much greater than 2000 solar masses, then your ripping radius will be after you've crossed the Schwarzschild radius. No, they are black, as in they don't let light escape, but there might be other things that are much more bright happening around them. Yes, exactly. So if the mass of the black hole is around 2000 solar masses, then you will be ripped apart exactly at the Schwarzschild radius. So if you want to see what's inside a black hole, you might want to pick one that is bigger than 2000 solar masses. We're reading from this book called Foundations of Astrophysics. It's a textbook for astronomers and astrophysicists, written by Barbara Ryden and Bradley M. Peterson, who are both professors at The Ohio State University, where I went to school. One strong candidate